All right. If we take our numerator and we rewrite it as a single fraction, we can find our LCD. Oftentimes, if you have just a number without a denominator, it might be helpful to write it over 1 just so you remember that you're dealing with a fraction there. So we need a factor of 1, a factor of x squared. So here's our LCD. So we take the numerators of the first term times any LCD factor missing from its denominator, what was missing from this denominator, and then plus the next fraction's numerator times what LCD factor was missing from its denominator. 1, just nothing, right? So I can leave it like that. That's all I have to do. Do the same thing with the denominator. Combine it into one single fraction. We need a 1 and an x squared. Take our first fraction's numerator 3 times the LCD factor missing from its denominator, minus 1 times the LCD factor missing from the second fraction's denominator, again not missing anything. So what we can now do is, instead of thinking of this as a division, a fraction over a fraction, we use this division bar to represent and convert to multiplying by the reciprocal. So the x squared gets moved to the numerator, 3x squared minus 1 to the denominator. You can cancel your x squareds, and now you wind up with your answer in the simplified form of 4x squared plus 1 over 3x squared minus 1. Did you cancel any common or any factors from the denominator? Yeah, so you do need to account for domain restrictions. What can x not be? 0. Okay. And so here would be our final simplified form for this. All right, let me show you method 2 really quickly here. The difference with method 2, anytime you have one or up to 2 distinct factors in denominators of all the terms involved, this second method can often be used much more efficiently. Okay? But if you go beyond 2 different factors, then it can get a little more time consuming. Okay? So if you have 1 or 2 distinct factors in your denominators, this second method treats the entire thing as a whole, and you're going to multiply this entire thing by a value of 1, and that value of 1 is just going to be the LCD of every fraction involved in the problem. So you need a factor of 1, a factor of x squared, factor of 1, a factor of x squared. Here's your LCD. So whatever your LCD for all the terms is, write that over itself. Again, I switch colors here to represent this x squared is simply tied to what's in the denominator, not to anything anywhere else. And once you do this, you're now going to treat the numerator and denominator independently. And what you're going to do is you're going to distribute across the top. So when we distribute an x squared across the top, we get 4 times x squared. Here we get 4 times 1 over x squared. Well, what's going to happen to these x squareds? So you get just the 1. In the denominator, going to do the same thing. We're going to distribute our x squared. We get 3 times x squared minus 1 over x squared times x squared. Again, the x squareds will cancel. So this simplifies and gives us our answer pretty directly. The disadvantage to this is you don't get to see the canceling of factors like you do in this first method. And so you just need to make sure you go back to the original form and check for domain restrictions. So in this original form, what do we know x cannot be? Is that shown in this simplified form? No, so you need to identify it on your own. Okay. Again, notice that the answers are the same. This second method will work this quickly or pretty quickly like this for almost all the problems that have 1 or 2 different factors in their denominators. Anything that has more than that, then the first method is probably going to be a better suit.